blinking. I do not know what's the reason behind this. It doesn't show anything.
Okay, okay. So now,
Yeah, now it's coming.
okay, sir. Can I start now, sir?
Sure, you can start this. So
Okay.
I just before you start, I just wanted to give a quick intro. Is that the NumPy is something is extremely important data structure in the library in Python. So in entire machine learning thing that you will be going to code up and learn and stuff like that, you will have to use NumPy now and then. Okay, so everywhere you need NumPy kind of thing. So be it like standard machine learning algorithms, or be it when we'll be dealing with some kind of neural network structure and so on. The NumPy is one of the most important library in Python. So please be little careful and pay attention to it. Okay, so lots of things will depend on this one. Okay, Shubhankar, you please start.
Sir, am I audible? Hello? Hello?
You are audible. You are
Oh,
audible.
okay, okay.
Mhm.
So, sir, actually, NumPy is a fundamental package which is used in Python, and it also function of working several mathematical tasks like linear algebra, Fourier transform, and random number capabilities. And we will discuss each of them in our upcoming slides. So, one might ask that we have already seen there are several data structures like lists, sets, dictionaries. So why do we need the extra NumPy arrays? So there are some advantages. And if I ask why are NumPy arrays are efficient than other data structures like lists, sets, or dictionaries, and the reason is the data is stored in a homogeneous and continuous block of memory in a primary memory or in RAM in case of NumPy arrays. But when there is when we use list, then it will be scattered across the system memory. So in time of fetching the values, it will be more efficient. And NumPy is actually written in C and C++. Underlying code of NumPy, if you see the source code of NumPy, you will see that NumPy is written in C and C++. That is why also it is very efficient than other data structures. And yes, and to install NumPy, you can simply write pip install NumPy, and automatically it will be installed in your machine. So, so if you go through the NumPy source code, and here is a link. It is the actual NumPy source code. Here you will see that there are several classes in NumPy packages, and it includes the attributes and methods and function. So first of all, I want to say little bit about class and objects. And if I simply say what is class and what is object, then I can say class is a data type and object is a variable of the particular data type. For example, I think all of us know how to write C program. So if I declare a variable like int x equal to 10, here int is a data type and x is a variable. So we can use this concept to understand class and object. So here int you can think as a class, and x, which is a variable, you can think as an object. And these several classes are there um, in NumPy package. For example, so if I want to create a NumPy array, so first we have to call this NumPy package import NumPy. And as I said, in NumPy classes, there are several things. One is attributes, and another is methods and function. And all these things, after that, the round braces are there. For example, you can see that creating a NumPy ND array object by using array round brackets, it is a function. An attribute which is like there will be that is not done, that is not be written as round brackets, and we will see in upcoming examples. For example, if I want to create an array using numpy array, then you have to create an object which is a here, and the type of the object is numpy dot array, and array here it is a function. So here we are passing the array object through the uh, uh, we are passing the array through the array function. So the square bracket is the array object and the round brackets are the function. So here it is mean passing an array to the function array, and a is a numpy any array object, and always numpy returns a any array object. Okay. So if I print, then and similarly for integer, for character, for floating point, there are several data structures, data types which are used in NumPy, and we will also discuss that. So you can say that it will print 1 2 3 4 and b as a and b. So one more thing, uh, instead of writing NumPy always, we can also write as np. So it is called as alias. So import numpy as np, and then we are going to call a equal to np dot array, and the rest will be same, and it will give the same result. And to check the numpy version, you can print this numpy dot underscore underscore version underscore underscore bracket. So we have already seen what is tuple and what is list, and the difference between tuple and list is mutable or modifiable or changeable, but tuple is unchangeable or unmodifiable. So we have seen here that here we are passing an array which is denoted by square brackets within the round brackets, and also we can pass a tuple within the function. And for tuple, the we have to write it as a round brackets. So here you can see that a equal to np dot array round brackets within round brackets 1 2 3 4 5. It says that we are passing a tuple in a function called array. Np is a package, dot within that package there is a function called array, and we are passing this tuple to the to the we are passing, and it will return. And there is a one more important thing: every function within numpy will be two things. One is parameters which will take, and another is what it will return. For example, the array function will take those as parameters 1 2 3 4 5. It can be tuple, it can be array, and what it will return is an object of type any array. So using NumPy, you can create any type, any dimensional array.
Uh,
Sorry.
I have a doubt.
Yes.
We said that tuple cannot be modified, right? So if we pass this as a tuple in NumPy, then can we edit this A?
Sorry.
Uh,
Okay.
before you started NumPy, some other sir, I think Suraj sir told us that tuple cannot be edited. I mean, if
Yes.
we are
Yes. 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 Immutable.
tuple,
It
then
means.
it cannot be edited.
Yes.
So if we are passing this 1 2 3 4 5 as a tuple into this array in
Yes.
NumPy, can we edit it?
Can we print it?
No, no. If I want to edit A,
No. No.
then
No. You can't. You can't edit it.
okay, okay, fine.
You can't edit it. That is why it is. That is why it is the difference between tuple and list. And you can't like use the dot add, because these functions are not available in NP.
Oh, okay, okay, fine, fine.
Okay. And I will show the errors which we often get if you type wrong functions or wrong attribute. Then it will show you the very good error message, and I will also show that. So how to create different dimensional arrays 0, 1 and 2. And we can say 0D array can be called as scalar, 1D array is nothing but a vector, and 2D array is nothing but a matrix. And one more thing is there which is called tensor. And I think all of you might heard about the tensor flow nowadays, and it is nothing but the operations using tensor. And what is the difference between different dimensional array and tensors? The difference is, in tensors there will be a matrix and there will be a depth in the matrix. For example, if you take a image, RGB image, there will be a matrix and there will be three layer, one for red, green and blue, and this depth is there. That is why it is called tensors. So now in this tutorial we will just see the 0D, 1D and 2D. So first, how to write 0D array or a scalar. So first, as usual, you have to call the NumPy, and then you can write a equal to np dot array 42, and you can print it, and ndim, it means the dimension of the array, which is 0. And similarly for 1D array, you can write as a vector or array, which we have seen, and the dimension will be 1. And similarly for 2D array, it is a 2 by 2 matrix, 1 2 3 and 4 5 6. So you can see the array here and the dimension is 2. And for high dimensional, you can write there is a, and in array there is a symbol representation like 1 2 3 4, and you can denote the dimension of the array ndim, n dimension equal to 5. So it will show the 5 dimensional array. Now we will see the array indexing. So for example, first we have created a vector or array which takes 10, 12, 30 and 14. And as Suraj said that the array indexing starting from 0. So 0 1 0 is 10, 1 is 12, 2 is 30 and 4 is 14. So array 1 will be 12. So, and it is straightforward. We can also add or multiply any elements using the indexing. For example, if I want to add the second index with third, then it will add 13 plus 14 equal to 27. And if there is if the array is a 2D array or two dimensional array, then also first we have to define the array. And if I want to fetch in right hand side, you can see that this array will be represented as row 0 1 and column 0 1 2 3 4. So if I want to fetch 1 1, then 1 1 will be 17. And likewise you can fetch any elements in this 2D array. For example, if I want to fetch this 10, and also Suraj said that if I want to fetch the array from backward, it will starting as -1. So if I take 1 minus 1, then it will give the 10. So if I want to print 1 minus 1 element, then it will give 10. Secondly, there is another very important characteristics which is called broadcasting. And the term broadcasting describes how NumPy treats arrays with defined shapes during arithmetic operations. And NumPy operations are usually done on pair of arrays on an element by element basis. For example, if I want to multiply two arrays A and B, A is written as 1 2 3 and B is 2 2 2. If I write A into B, then it will multiply this element by element. 1 will be multiplied by 2, 2 will be multiplied by 2 and 3 will be multiplied by 2, and it will show 2 4 6. And if I want to multiply a scalar value which is 2 here with an array, we don't have to clearly said that it is a scalar, it is a vector, it will automatically do this, and this is the characteristics which is called broadcasting. So for example, if I say a equal to np array 1 2 3, b equal to 2, and if I want to print a into b, it will automatically print automatically multiply 2 into 1, 2 into 2, and 2 into 3, which is 2 4 and 6. And similarly, as we have seen for list, dictionary, and there is a slicing. For NumPy array, we can also use the slicing. And for slicing in Python means taking elements from one given index to another given index. For example, to slice, first we have to specify the start and end index. And also, if I want to fetch after a certain steps, then you can also define the steps. For example, we have defined a vector which is 11 12 13 14 15 16 17, and the index starting from 1 to 5. And if I want to fetch 1 to 5, then we have to write just print within bracket 1 is to 5, and here it will print from index 1 to index 5 minus 1. It is important, and it will not 5 minus 1 means 4. So you can see that starting from 0 0 1 2 3 4 5, 4 is 15, so it will print 12 13 14 15, and not up to 16, which is 5. It is 5 minus 1. And if I want to slice elements from index 4 to the end, you just have to write 4 is to blank and then square bracket. It will print from 4 to end to the end. So 4 is 0 1 2 3 4, 4 is 15 15 to 11. And similarly, if you want to print from the beginning up to 5 minus 1 means 4, then you have to write nothing is to 5, then it will print from 11 12 13 14 and 15. And similarly, if you also fetch this array from backward, and if you want to slice from backward, then you have to use this minus sign. So if you want to slice from index 3 from the end to the index 1 to the end, then you have to write minus 4 is to minus 1. Here minus 4 means from end 4 minus 1. From end 4 minus 1 means 3. 0, 1 2 0 1 2 3, which is 14. 14 and index 1. 1 means 16. So 14 15 16. And similarly, as I said, if you want to fetch after a certain steps, like first 12, then 14, then 16, then you can also do that using the step, by including the step. So it will just 1 to 6 and then 2, means I want to slice from the index 1 to index 6 minus 1 after 2 steps. So it will first start with 12, it is 1, and 6 minus 1 is 5. 1 2 3 4 5 is 16. So it will first 12, then 14 because the step size is 2, and then 16. And similarly, if you want to return every other elements, means every elements after 2 size, then it will, you just write is to 2. It means first it will 11, then 13, then 15, then 17 after 2 steps. Just write here 2 means the step size is 2. And another one, it is important that if suppose there is a array of 2-dimensional or 3-dimensional or 4-dimensional, and you want to slice a particular element or particular row in the matrix, then you have to you can also do that by this method. So first of all, array, and this first one is the element. So here you can see that there is a 2 element, first one is 11, 12, 13, 14, 15, and second is 16, 17, 18, 19, 10. So this one is first one is 0 and second one is 1. So here it is saying that we want to take second element and slice it from 1 to 4. So it will take this part 16, 17, 18, 19, 10 and it will slice from 1 to 4 minus 1, which is 3. So 17 to 19. And similarly, if you want to slice both these elements, means you want to slice this and this, then you have to write 0 to 2. Then it will slice only 0 first this element and then this element. And for both the slicing will be 1 is to 4. 1 is to 4 means from 1 to 4 minus 1, which is 3. So it will show that 12, 13, 14, 17, 18, 19. And if you say 0 is to 1, then it will only 0, the first element. First element here is 11, 12, 13, 14, 15. And it will slice 1 is to 4. It means 1 to 3, 12, 13, 14. And now the NumPy data types. There are 5 data types there is in NumPy. One is string, integer, float, boolean, and complex. For example, as Suraj mentioned, strings nothing but English sentence or word, like it is a string. Integer 1 2 3, float 1 point something, 2 point something, 3 point something. Boolean is true false, and complex is there will be I and j, 1 plus 2j, 2 plus 3j, like that. So if I create an array and we want to print the data type of the array, just write print a dot d type. It will print int 64, and there will be 64 int 64 maybe, or int 32, and int 64 tells the Python is storing each value within the column as 64-bit integer. And if it shows that int 32, then it means that the column has a 32-bit integer. So yes, so here what we have done is we have first created a floating point values. So it are float 1.1, 2.2, 3.3, 4.4, and we have forcefully mentioned the data type will be integer. Then what it will do is it will automatically typecasting the array. So it will print as 1 2 3 4, and the data type will be int 32. And similarly, we can also typecast an array from one to another. Suppose there is an integer array suppose there is a floating point array which containing 1.1, 2.1, and 3.1. So we want to typecast it from float to int. Then just write array object. This is an object array which is defined here, array np.array, and just as type in bracket I. It means integer. So it will convert it from float to int. And if you now print it, then it will show that 1 2 3 and then int 32. And next, suppose we want to see the boolean data type. So in Python, 0 is denoted by false and every non-zero element is denoted by true. So if I write np.array equal to 0, -1, and 3, and now we just typecast it to boolean data type, then it will print 0 as false, -1 as true, 3 is true. As I said, non-zero is true and 0 is false, and data type will be boolean. And next is NumPy array. Can be modified or can be written as two type. One is copy, one is view. And the main difference between copy and the view of an array is that copy is a new array and the view is just a view of the original array. And we will elaborate it with an example. For example, first I have defined an array which is np.array 1 2 3 4 5, and we have called this function. array.copy. Array.copy means there is a array method, and in this the first whole package is np, and there is a function called array, and within that there is a method called copy. That is why first np dot array and then x equal to array dot copy. Then it will call the copy function, and then I want to modify zeroth index in this array. So it will I will write x0 equal to 42, and if I print the array and the x, you will see that the array is as it is 1 2 3 4 5, but x is changed to different, which is 42 first, 2 3 4 5, and that is called copy. So in
What will
conclusion,
happen?
sorry,
What will happen if you just assign x is equal to ARR? Just not using copy.
x equal to arr, then it will then whole array will be copied in x.
So why do we need copy command if we just can assign?
Any changes?
Yeah, if you just assign, it will assign the reference. Means both, if you do x equals to ARR, both x and ARR will point to same memory location. Where if you use the copy, then the total data in ARR will be copied to a new location and x will be assigned that reference. Okay.
Okay.
Okay, then next for view, similarly you can do it, and if you change the zeroth index, then it will change both the original array and the new array. So it will show the array is 42 2 3 4 5 and the new array is 42 2 3 4 5. And conclusion, we can say that the view does not own the data, and any changes made to the view will affect the original array as well as the new array. Now NumPy array shape, and the shape of an array is the number of elements in each dimension. For example, if I define an 2D array which is 1 2 3 4 and 5 6 7 8, and now if I print array dot shape, then it will print 2 4. It means 2 rows 4 columns. And it is very important to note that array dot shape returns a tuple object. Why it is tuple object? Because the 2 4, it is written in round brackets and followed by comma, so it is 2 4. And why it is tuple not list? Because it is immutable or unmodifiable. And we often commit these simple mistakes, which I want to tell that if I write array dot shape and the function symbol function brackets and then close, then it will show that the type error is tuple object is not callable. What does it mean? So if you see in this array function, in array class, there is nothing called shape function. There is no function called shape, and shape is an attribute. So you can't call an attribute like this round brackets. This round bracket means a function. So you are saying np to, numpy that just call the shape function, and it is showing clearly that tuple object is not callable. It means it is a function, you can't call it. It is an attribute, so you just have to write array dot shape. It is one mistake. And second is, if you write array dot type, so it is the opposite of here. Type is not attribute, so it will show that numpy dot array object has no attribute called type. It is another commonly committed mistakes. So now it is numpy array reshaping, and reshaping means changing the shape of an array. And why do we need that? Because in we all know while doing addition, multiplication, or any mathematical operation, we have to match the array size. For example, if I want to multiply a 2 into 4 with 5 into 4, it will not do that, because the column size of of matrix A and column size and row size of matrix B need to be same, and that is why this reshaping is very important. And before doing any type of multiplication or addition or any type of mathematical expression, we have to clearly see that what is the shape of these two matrices and where the reshape is very important. So for example, there is an array 1 to 12, and we want to reshape it into 4 into 3. So just it will show 1 2 3 4 5 6 7 8 9 and 10 11 12. And reshaping application, which I have discussed, that during any matrix operations like addition, multiplication, etc., it is required to match the size of the matrices. That is why reshaping is important. And flattening is also very important in image processing. What happened, as I said, image is denoted as a 2D matrix, and if you want to classify an image, you have to pass an image to a neural network, and then it will classify what this image is. So but there is a problem. So first you have to flatten this whole image to a row major order or column major order, because in RAM the pixel values are stored in 1D format. That is why we have to first compress or first modify this 2D array into a 1D array. That is called flattening. For example, there is a 2D array what is 1 2 3 and 4 5 6, and you want to flattening it. So just type dot reshape -1, and what -1 means, and here -1 means new shape should be compatible with the original shape. What does it mean? Suppose here the array size is 2 into 3. The new reshaped array will be 6 or compatible with 2 to 3. So what is the size of the matrices which is compatible to 2 into 3? There can be 3 into 2 or 6. That is compatible with 2 into 3, but you can't say 4 into 2 is compatible with 2 into 3, because in 2 into 3 there are elements numbers is 6, and in 4 into 3 the elements number is 12. So it is not compatible. And -1 means it will give this array which is compatible with the original matrix. So that is why -1 is used here. And if you print new array, it will flattening it 1 2 3 4 5 6. An application, as I told, during image, which is nothing but a 2D matrix of pixels, classification using neural network, we have to first flatten the image in row major or column major order, because RAM is a 1D array, and then you have to fed to a neural network for classification, and that is the widely used flattening application. And as we have seen that we can iterate list sets using for loop. So you can also use for loop to fetch all the elements. So it is nothing but for x in a print x. And for 2D also you have to use two for loops, or you can use, there is a function called ND-enumerate, which is a multi-dimensional index iterator, which return an iterator yielding pairs of array coordinates and values. For example, 1 2 3 2 4 5 6. So what will return? It will return the corresponding index and the value. So for 0 0 it is 1, for 0 1 it is 2, for 0 2 it is 3, and likewise 1 2 is 6. That is this ND-enumerate is doing. And secondly, you can also join two arrays using concatenate function, which is included in NP package. So NP dot concatenate function within you are passing two array object, which is array 1 and array 2, and what you will return, it is also an array. So if you print it, it will 1 2 3 4 5 6. And if you want to split it, and if you want to split it in two parts or three parts, or sorry, two subarrays, six subarrays, then you just first define the array, and how many subarrays do you need, you just mention it using array underscore split. So array comma 2, then it will split the array into two subarrays, which is 1 2 3 and 4 5 6. And similarly, suppose there is a matrix which is 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5 6 into 2 size matrix, and you want to split into 6 subarrays, then you just write np dot array underscore split array comma 6, then it will split it into 6 subarrays. And if you want to print it, you can print it. So I have printed it here. And also, if you can also search for an element in an array. For that, you have to use this where function. So what where function is doing is first we have to see the syntax of where. And if you go in NumPy web page, you can see that where, then the condition between x and y, and where x and y depending on the conditions. Suppose here is x is array and 4 is y. So I want it means that return indices where the values are 4 in the ND array. So in this array where the values is 4, in array index 3, in 5, in 6. So it will print the index number 3, 5 and 6. And if I want to print the even elements, the indices of even elements, then just where call the where function, and you just feed your logic here, which is array percentage 2 equal to 0, then it will show the indices of even element, which is 1 3 5 7. And for you can also use NumPy for sorting arrays. There is a sort function which will take the array object, and it will sort it. So 0 1 2 3. So we have passed 3 2 0 1, so it will 0 1 2 3 it will pass. And secondly, if I pass the array banana, cherry and apple, if I sort it, then it will sort it in alphabetical order or dictionary order. So first will be apple, then banana, then cherry. And you can also do it for 2D 3D, any type of matrix, any dimensional matrix. And there is a method called random numbers. You can also generate random numbers using NumPy. So what so in NumPy there is a function or class, you can say random, and in that there is a called randint function. So if you write x equal to random dot randint 100, what it will do is what it will tell it, that generate a random integer from 0 to 100. Then it will print 75, and each and every time you will get a different number, and which is exclusive 100. You will never get 100. You will see 0 to 99. And rand method return a random. So okay, and if you want to print a 3 cross 5 matrix using this randint, then you can also do it. So what it is saying, that generate a matrix of size 3 into 5, and the element of the matrix will be from 0 to 99. And you can see that the matrix is of size 3 cross 5, and each element is from 0 to 99. and each and every time if you run this run this snippet, it will show the different elements in this matrix. That is why it is random. Mathematical operations, and there are several mathematical operations you can use, which is add, subtract, multiply, divide, power, remainder, etc. And there are several statistical functions also, which is median, standard deviation, average, mean, variance. And we have shown here only the average of these elements in this array. And lastly, you can also plot. Plotting is used by matplotlib, which will be discussed by Sujoy sir now. But what what it has done is, you can also sample sample from a uniform distribution. So what does it mean is, any value within the given interval is equally likely to be drawn uniform. For example, if I write numpy.random.uniform, so it is calling numpy package first, then random, then uniform, and which is 0, 5 and 250. So here 0 is the lower bound, 5 is the upper bound, and number of samples is 250. So what it will do is, from 0 to 5 it will randomly sample 250 points. And if I want to plot the histogram of that using matplotlib, then it will show like this. And what does it mean? It means an x-axis is 0 to 5. You can see that lower bound is 0 and upper bound is 5, and y-axis is showing how many numbers of times 0 is sampled. And likewise, so 0 is sampled nothing but like it is 58, 1 is 48, like that. And this is the these are the sum operations, characteristics, or mathematical operations you can do using NumPy. Thank you. So if you have any question, you can ask. If I can answer, I will try.
Okay, thank you, Shubhankar.
Okay.
Anybody has any question? Okay, all right. So Sujoy, are you there?
Yes, sir.
Yeah. So please to start it.
Okay.